Hi, I'm Dr. Kamakshaya. I'm making a series of video demonstrations on spreadsheet modeling using Excel software application. In my previous videos, I've explained the basics of Excel and also a very significant, very important topic called chi-square test. In this video demonstration, I'm going to explain how to perform t-test in Excel spreadsheet. Now I have a hypothetical situation here. I have a data variable called delay time, and this is actually the number of days it has taken for a e-commerce business to deliver the goods to the buyers. Usually the goods need to be delivered with no delay time. So delay time should be 0. So it should not be anything other than 0. So how are we going to take a decision whether this is actually a sample data of some for the 19 days of data. The first day, it's not the day actually, it is a customers, 19 customers. The first customer has the goods reached the customer after 11 days of delay, and second customer, the goods reached to this customer after 19 days of delay, like 3 days, 12 days, 27 days, 3 days, and so on and so forth. The maximum, I think 27, I don't know, I need to check, average amount of delay. So what is 13 days, and the maximum delay in this sample data of 19 customers. So 29 days, that's not good. And a minimum delay is 3, I guess. So 13 days is also not a good thing. This is just a simulated data set for a hypothetical situation where we are assuming that these numbers represents delay arrival of goods to the buyers. Okay. Now, what should be the ideal value for the delay? It should be 0, right? So my null hypothesis is going to be the mu is equal to 0, right? And my alternative hypothesis is going to be mu is not equal to 0. Okay, so anything other than, so the mu is anything other than, mu means the average in the population, right? So the sample average is 13.84. So we are going to take the inference. Okay, that's why we call it as inferential statistics, right? T-test helps us to infer what is happening in the population based on the sample data. Now this one sample t-test is we are going to decide, though we have some certain delay which appears to be so alarming in this scenario, but in the population it could be 0. That is what is our proposition, okay, assumption. Okay, we are going to validate our proposition using this hypothesis, okay, null hypothesis. So unfortunately in Excel we don't have a function for one sample t-test. We need to depend on the formula. So what is the formula for this student t-test? Now it is very easy. It just talks about the standardized difference between the actual mean and the hypothesized mean. So in this case I have 13 dot, this is my actual mean and my hypothetical mean is 0. Now I need to divide that with standard error. Okay, the difference between the actual and the hypothesized mean should be divided by the standard error, and the standard error is calculated by dividing the square root of sample size under standard deviation. So here S stands for standard deviation, N stands for sample size, X bar stands for actual mean, and mu naught stands for hypothetical mean, hypothesized mean, okay, whatever it is. So what is my actual mean? So my actual mean is this one. Okay, I calculate here. X bar is the average of, okay, this range. Okay, fine. And now my hypothetical mean, that is mu bar, is something 0. Now my standard deviation is STDEV. STDEV. You can say take SB, doesn't matter, like you can take standard STDEV, this one, okay, and you can just calculate. S stands for sample, P stands for population. If you are interested to calculate the statistic for sample, you can go for yes. If you want to do it for population, you can go for something like this, which I don't like to cover in this video. Now what is standard error? Okay, standard error is standard deviation divided by square. I can just use square root of I can say rows, number of rows where this, so it should be 90, right? So you can cross check that. So this is standard error. Okay, now we are going to calculate t statistic. Okay, that is going to be, I'm going to open the brackets because I need to x bar minus mu, isn't it? So where is x bar? This one, minus 0 divided by standard error. So this is the t statistic, which is, it is very large. Now we need to calculate the p-value for this t statistic, right? So how are we going to do that? So to calculate the p-value, we need to use a particular function called t distribution. So this t distribution is going to ask for t statistic, and then there are different types of, here the tiles is there. You can also use other functions like, t dist RT stands for right tile, L. Okay, we'll go for t distribution. Is distribution RT or two tail. You can go like that. Okay, let's go for it is actually a right tile distribution because t statistic is positive, right? So we'll go for right tile test RT, and now this is the t value, and what are the degrees of freedom? Degrees of freedom is n minus 1. So how many values we have? So rows of this, which is obviously 19 minus 1, so that is degrees of freedom. So now this is actually the p-value, which is 0. Okay, 0.000007 zeros. So here 6.17 into 10 to the power of minus 7. So that is actually 0, right? So now what is the t critical value? So just for cross check, critical value is going to be t inverse. Okay, here the probability, my probability is 1 minus 0 dot because it's right tile value, right, 0.5, and degrees of freedom rows, I can just directly use 19 minus 1, but instead of that I just want to follow the discipline, the convention. Now this is actually the t value, right? The calculated t value is far above the actual t value. So at 5% significance level, we can arrive at the decision that we can safely reject the null hypothesis that the mu value, the actual delay in the population, is 0. Though we can reject the null hypothesis, arriving at the decision that the actual mu value in the average amount of delay in the population is not 0. Something which appears to be 13, something which is 13 appears to be true. So this data gives us some certain sense that there is a problem in delivery of the goods to the customers, and there is a lot of delay, and the sample average is not 0, and average delay time is not 0, and there is a caution, there is a caution, the data signals caution, and there is a concern in the data. So it calls for the concern as far as the time delay is concerned. Okay, thanks for watching this video. This is how we perform the t-test inside spreadsheet applications such as Excel software application. Stay tuned for the new content, and bye bye for now.